And I've been working as a SQL Server database administrator for the last 3 years for the MNC called CGI. Right now based in Bangalore, and mainly I've worked on database administration roles for the last uh, 3 years. And today I would like to make you go through some of the basic topics related to SQL Server. So prior to that, could you just tell me what's your prior experience in SQL Server, if you have any? Hello?
Hello?
Naveed? Yeah. Can you just give an introduction of yourself? Yeah, go ahead.
Yes, my name is Naveed. I am basically working for a health insurance company, and I have a little bit of experience in IT. I basically work in IT department as a help desk support, just working with ticketing system, and have a little bit, not much, but just a little bit knowledge about SQL. And when basically just company is the company I'm working is pretty much all we work in the IT department, so I'm basically looking to move up with the company and or maybe look for another some job in SQL related.
Okay, good. And what's Eritrea?
Yes, can you hear me?
Yeah, go ahead. So do you have? Yeah, go ahead.
My name is Eritrea, and my background, I went to school for computer information system. I've taken a database before. I have very small knowledge about SQL Server, but I wanted to brush what I've actually forgotten, so I wanted to be a DBA. Eventually, that's the path that I want to go.
Okay, good. So, to the best of my knowledge, I will take the classes, and in case you have any questions, you can. I'll provide you my account name, so you can post in your questions, so I can give you more clarity on the questions that you have. Yeah. Okay. So we'll go ahead. I'll just share my screen. We'll be just going through the beginning sessions, which will be related to SQL Server architecture. I won't be taking care of the architecture today. I'll be just taking care of the fundamental units in particular SQL Server. So, yeah, I have for this. Hello?
Yeah.
Okay, I'll try to clear some. Yeah.
Ben, quick question. I know you're going to do a demo today, but would you be able to provide or show us the list of information you will be covering if we do attend the course? Like a syllabus?
Syllabus. Could you help me out in that? Who is that from Trainingicon? Hello?
Hello.
Who's there from?
It's Aditya.
Aditya. So Aditya, help me out in that. Are you able to see my screen? Is everyone able to see my screen? Hello?
Yes,
okay.
we do.
Okay. So I'll be just going through some of the slides that I have used in my company. So I was not able to create new slides, but I'll be using these slides to help you out today to understand somewhat about the SQL Server architecture. So the main things that we will try to cover today would be what is pages and extents and the architecture of them, and secondly, the files and the file group and the architecture, and the transaction log architecture. So these three will be covered today within the time, stipulated time. Okay. So basically, what are pages? So just for understanding of that. Yeah, pages are a fundamental unit of data storage in SQL Server. So, and an extent is also a collection of 8 physically contiguous pages, and it helps. The extents help them to manage the pages. So, what are pages is data in SQL Server are stored in units of pages. So when we are talking about SQL Server is a database management system which stores data for retrieval purpose of for the application, right? So these data in the drives will be stored in units of pages. So each page is of a size of 8 KBs, kilobytes. Okay? And when you create a database, by default, a database will have 2 types of data file. Two types of database files. One is the data file and other is the log file. So each data file will have multiple pages inside it. Okay? So that's what it is written. The disk space allocated for a data file in a database is logically divided into pages, and it will be in a serial order. The pages will be numbered out. Okay, and each time when you want some data to be retrieved from the SQL Server database, it is retrieved as pages, right? As a SQL, like every other application that runs on the Windows, we know that when you want to run an application in a Windows server, it has to be first read into the memory of the Windows server, right? The memory or the RAM. It is read to the RAM, and then it is read by the application, or it is viewed by the application. Okay? So the application to be viewed, it has to be first read to the memory, and then from the memory it is being accessed. So it's the same way the SQL Server works. So whatever data that you want to retrieve, right? Whenever you want to retrieve some data, that data has to be first read into the memory, and from the memory it is accessed by the application. That will help you in the faster retrieval of data. Okay? Because when you consider a server which is in production, in live environment, if there's a SAN drive of consider 1 TB, okay, and that SAN drive is located in some 1,000 miles or 100 miles away from where the actual server is. So each time when the data has to be retrieved, it has to go to a network, read the data, and give it to the user. So if there is no concept of memory, the data retrieval will be very slow. So to speed up the data retrieval process, we have the RAM, and so that's the reason the pages are read into the RAM, and from the RAM it is read by the application. Any questions in that? Okay, go ahead. So just a little more clarification on the pages that we are talking about. Like an atom, it is the most fundamental unit of matter. Pages are the most fundamental unit of SQL Server. So as I said earlier, in SQL Server, the page size is always of 8 kilobytes. So when you do the calculations, per megabyte we'll have 128 pages. These pages are nothing else other than memory spaces, just blocks of memory. These pages are actually memory blocks, which is there in the drive. Okay. So when we go inside the pages, we see that each pages will have a 96-byte header, which will store the system information about the page. So all the metadata about a particular page would be in that header of that particular system. So for consider, it will be like so if when the application or the SQL server wants to read a particular page, it will look at the header. When it looks at the header of the particular page, it will understand what is content of that particular page, or what type of page it is, what's the page number, how much free space is there in the page. All those details will be there in that page header. Okay? Okay. Now we'll discuss these things are this fundamental units. Just keep these things in your mind. It will help you to understand further when we go into the architecture or when we exactly start our work. So these are just for information basis things. Okay. Now when we talk about different types of pages, we have data pages, which will store the data, index pages, which are used for indexes. I'll come back to those things later. Text and image and global allocation map pages, share global allocation map pages. So these are like some types of pages which has a different function. Not all pages are used to store data for retrieval. Some pages are used to store information about some pages. Like the global allocation map and the shared allocation map pages will have information about other pages. Okay? Okay. Any questions till now? If you need any clarification, just let me know. So before I move forward. Yeah. Anyone? Naveed? Triya?
So, quick question. So, once the 8 pages filled,
Yeah.
what happens?
Yeah. So what happens is for these pages, once it is filled up, another page, new page will be given, and these pages are linked together. You must have learned in computer science about linked list. So some sort of architecture where one page is pointed to the other page, and because when it is actually a memory page size, right? It's a memory block which is given for adding data. So when you do, like for example, in SQL Server, you want to insert some data into a table. Okay, you newly create a table, doesn't have any data in it. You insert a particular row into it.
Okay.
So when you insert a particular row into it, a page is given, and the row is inserted into that particular page.
Right.
Okay, and once this 8 KB is completed, like it's been filled up, then a new page is dynamically given so that you can insert more data into it. So these dynamically it is being taken care of by the SQL Server itself. We don't have to worry about it. We can restrict the size of the tables and all that will come in the later part of the session. But right now, just for understanding, a pages will be dynamically given by the SQL Server to insert data. Understood? Will that answer your question? So usually a particular row of data, for row, when I mean row, means like if a table, for example, it has particular column called, a table called employee may have a column named employee ID, employee name, employee manager name, employee salary, or something else. Okay, so that when you add the first row of data, that row should be within 8 KB. Okay, the size of that particular row. So every content, every character that you add in is actually having a particular byte, right? Each bytes, it will be bytes by byte. It will be added to make 8 KBs. So we had different versions of SQL Server. Before SQL Server, right now we have 2014, which is still on a release state, and we had SQL Server 2000 till the version SQL Server 2000. We had a restriction that every row of a particular table should have only maximum of 8 KBs. So if you have a huge amount of data like an address or some XML file to be added into this table, it will never allow you because it will be more than 8 KBs, right? So that's the reason from SQL Server 2005 onwards, we have different types of data pages, which I'll come across later. Okay. So currently, did it answer your question, Shreya?
Yes, you did. What I was trying to understand, I think before when I used to read about it, anything that is more than 8 pages KB, if it goes to the second page, it create a split. So I was trying to understand what the split was. So obviously you're saying if it goes to the second page, is that considered to be a split?
Yeah, page splits happen. Yeah, it is a page split, but page split happen in cases where there is a different page added into it, and there's an overflow. Data is being overflown to one page to other. In that case, we have a page split coming into the session. Okay. So, but if it is a different row of data, I'm talking about a single entry, single row entry. If you have second row entry, which is again of near to 8 KB, it will create a different. It will be allocated of a different page. A new page will be created. I'll try to make you understand these things a little more in the future, how the data is put into pages and all. Right now, we'll just go through on the high level, what is pages, what are the type of pages, right? And then we'll try to understand how data is inserted into the pages, what causes page splits, right? You must have read about page splits, yeah. So what causes a page split and all that. Okay? Right now, just we'll go on the high level, what are the pages and what are the page types, and then as we move on, we'll just go into the explanations. Okay. Moving forward, then we have the global allocation map pages and the shared allocation map pages. These map pages would have information about the extents and how they are allocated. Okay. So you must have read what is an extent. So extent is a collection of 8 pages. 8 contiguous pages will be called as an extent. Okay, so that means 8 into 8, which makes 64 KB. So each extent will be of a size of 64 KB. And this global allocation map or the shared allocation map would be speaking about what is the extents and what are the extents inside, what are the extents available, which will help you in retrieval process. Because before a SQL Server directly hits the pages, it will be checking for the extents. Once you narrow it down to the particular extent, then it will read the particular page in that extent. And once you narrow it down to the particular page, it will read the particular row in that particular page, which will help you to retrieve the data. So extent is just a bigger memory structure which contains 8 KB memory, 8 KB into 8 pages. And the page free space page will contain the details about what are the pages that are allocated and how much free space is there in each page. So per extent, there will be one page which will be called PFS or the page free space page. This page will tell you how much free space is there in particular page. So when there is a new row to be added, okay, it will first check in this page free space page and find out which page has space enough to put this particular new row. right? So this information is given by this particular type of page called page free space or PFS page. Index allocation map is the next type of page, which will contain the information about the extents that are used by the particular table or index. So what per allocation unit? Yeah. So what kind of extents are used, and what is it? Because there are two types of extents that we will come across later. So what kind of extent is used by the particular table, or more information about the indexes will be provided in the index allocation map. You must have some idea about indexes. If not, it's a huge topic as it is. We'll come to it later. Just for your information, index is a structure which helps you to retrieve data faster. Okay. For example, when you have, it's like the indexes that you have for a book. You buy a book, right? You have an index in the beginning of the book which says, okay, on this particular page we have all information about this particular topic or some other topic. So it will help you to point out what data is there in what page. So it will be faster for the SQL server to retrieve that particular page rather than going to the whole page, whole book, right? If your book didn't have an index, and if you want to find out about a particular topic, when you talk about a computer science book, you have a particular topic of operating system. So if you don't know where it is written about operating system, you have to either go through from the first page to the last page. But if you have an index, the index will tell you, oh yeah, on this page we have operating system explained. So then we'll go to the particular page, read from that page, right? So this is a similar concept when it comes to indexes. Okay? Yeah, can I go forward, or is there any clarification required? Okay, moving forward. Little more understanding about the pages. So each data rows are put into page serially. So data row is nothing other than a row of data inserted into a table or updated data. So each time when a row is inserted, so the pages will be added one by one. The rows will be added one by one, starting from the immediately after the header. And at the end of the page, there is a row offset table, and that will have one entry for each row of page. So from that row offset table in that particular page, you can understand how much of data is being used, how far the first byte of row is from the start of the page, right? So it will be able to, in a way, it will be able to understand how much of space is being used by the particular page. Okay, so that's just the understanding about row offset table and how data is inserted into a page. So as we see here, data is inserted into the page serially. So if you do insertion of one particular row of data into a table, and then another insertion after that, it will be inserted one after other in a particular page. Okay, I'll try to show you how the pages are data is inserted into these pages in the later session. Okay, as we see here, right? See in the SQL server, this is a pictorial representation of it. So we have a page, we'll have a page header. As every page will have a page header which will contain the information about a page, what's the page type, right? What's the page ID, how much space is used by the particular page, all those details will be there. And then when you add a row into it, it will be added serially. So first row is inserted into that, and then the second row, and the third row. And the row of the table at the end would show you what is the first byte, which is how far is the first byte from the starting of the header. So in that way we'll be able to calculate how many rows of data is added into that particular page. Okay. Okay. Now we'll talk about in cases where pages cannot contain the rows which is being added. So prior to SQL Server 2000 and till 2000, SQL Server 2000, we didn't. Only each row can have maximum of 8 KBs. But since SQL Server 2005, we have this overflow allocation unit, which will help you to have a row of data which is greater than 8 KB. Okay. So if you read through it, you will see that maximum amount of data and overhead that is contained in a single row on a page is 8 KB. However, this doesn't include the data stored in the text or image page type. This restriction is relaxed for tables that contain varchar, nvarchar, var binary, SQL variant columns. So you must have heard about different data types which is there in SQL Server. Just for some sort of clarity, in SQL Server, to keep a data is not just kept as characters. It is kept in, the data can be numeral characters, it can be alphanumeric characters, and it can be XML characters, and it can also depend on the size. So for including data of different types, we have different data types. So these data types will be, when, for example, over here it is mentioned varchar. Okay, varchar is a data type which will help you to store data of the type which will be alphanumeric, as well as it is under the ASCII code. You must have heard about Unicode and ASCII code. So, sorry, so this kind of data is being stored in varchar, or in varchar you can store non-Unicode data also. So these have a huge, bigger size. We can add in bigger data into these particular data types. Yeah. So when you talk about pages which will have data types of these variants, it cannot hold in. We need a different type of data pages, which we will be talking about later. Okay, so here we come up across the details on it. So the total row size of all fixed and variable columns in a table exceeds, whenever it exceeds 8 KBs, the SQL Server dynamically moves one or more variable length columns of 2 pages in overflow data allocation unit. So when you have a data row which is greater than 8 KBs, it consequently moves some of the columns in that particular row to a different page. That pages are called row overflow data allocation unit. It's a type of data page, but it will move the columns which have the largest width. So this is done whenever an insert and update operation increases the total size of the row beyond 8 KB. I'll just show a small demo on that. So over here, see, we are trying to create a table with 2 columns, product name and product description. Okay, and varchar is the data type of that particular table. Okay, and this is the maximum size, number of characters that can be added into that particular column. So 4,000 characters is the maximum size that can be added, but we have defined it to be 4,000. Okay, here it is 1,000. When you create such a table, okay, and here this is a query which will make you understand what kind of page is being created. See, here it creates a data type of in-row data. In-row data is a data page where the total size of it, whenever it is below 8 KB, it becomes a data page, and that data page is called in-row data page. Okay? But if you try to add one more table, one more column to that, which is of size 4000, so it becomes 4000 plus 4000 plus 1000, 9000 characters, which is more than 9000 KB. So what happens, you will just understand that right now. When you run this, and you check what is the internal structure of it, you see now there's a different allocation unit set. See? Row overflow data. This is due to the reason that when you do that data type is greater than the size of the 3 columns exceeds 8 KB. That's the reason it creates a new overflow data unit to which those pages are assigned to. Okay? Any questions? Hello?
Hello?
Yeah. Any questions?
No.
Yeah. Okay. Moving forward. So that's how, in that case, only that particular, whichever is the largest column in that particular table will be moved to a different allocation unit, which is also a kind of a data page. Okay. So when a column is moved to a page in row overflow data allocation unit, a 24-byte pointer on the original page in the in-row data allocation unit is maintained, right? So this will help you. So whenever a column is moved to a different allocation unit, that is row overflow data allocation unit, the original page, which is an in-row data page, will have a 24-byte pointer which will point to the row overflow data allocation unit page. So that in that way, the server will be able to understand when you run a query, when you want to select the data out of it, which all pages has to be called. Because right now it is kept apart. You must have known what is a pointer, right? You must have learned what's a pointer when you were studying computer science. So, for your to refresh your memory, a pointer is nothing but it points to the address of the different page. So each page has a page address, right? So this pointer, the in-row data pointer, will help you. In-row data pointer will have the address of the overflow data allocation unit pointer unit page. So in that way, when you retrieve data, you will not retrieve one page. Even for retrieving data of one row, you will have to retrieve 2 pages, right? Okay. If the subsequent operation reduces the row size, SQL Server dynamically moves the column back to the original page. Okay. Next. Okay. A table can contain a maximum of 8,000 bytes per row. This is 8 KB. But as we have talked about earlier, this is just a repetition of the things that we have talked about earlier. We'll just move forward. Now just talk about extents. So I must have told you before what is an extent. So extent is a basic unit in which a space is managed, and each extent will have 8 physical contiguous pages. Sorry, just give me a minute. I'll be back in 2 minutes. Okay. Aditya.
Hello?
Hello.
Can you hear me?
I'll be back in 2 minutes.
Sure.
Yeah. Okay. Thank you.
Saya break dulu sana terus kita.
Hi, I'm back.
Hello.
Okay. So I'll just go forward with the rest. Thanks for waiting. Okay. So an extent, as I've said, is like a collection of 8 pages, and it'll help you in space allocation. And SQL Server will be allocating pages to a particular table on basis of an extent. Okay. So in SQL Server we have 2 types of extents. One is the uniform extent, where all 8 pages will be used by one particular object. So when you talk about object, it's a particular table. Okay. When you newly create a table which doesn't have any data in it, and there will be a page allocated to that, that page will be a part of a mixed extent, not a part of uniform extent. So when you talk about mixed extent, it can be shared by up to 8 objects, different objects. Okay? An extent can have pages which will be from different objects, owned by different objects. So as you see in the last point, a new table or index is generally allocated pages from mixed extents. When the tables or index grows to the point that it has 8 pages, it then switches to use uniform extents for subsequent allocations. Right? So when a new page is created, always from a page will be allocated from a mixed extent. Once the table size goes beyond 64 KB, which is 8 pages, it will be switched to a uniform extent, where all the pages of that particular extent will belong to particular object. So when you do data retrieval, it will be much more faster because it just have to read that particular extent. The extent will have the complete data about that particular object. Okay. So that's the same case when you create an index for a particular table. So in this diagram you will be able to understand more. So when a mixed extent, it can belong, that page can belong to a table 2 or index 1 or index 2 in table 2, table 3. So different objects pages are used to create a mixed extent. While in a uniform extent, all the pages belongs to a particular table called table 1. Got it? So when a table 1 was first created, it would have been a part of the mixed extent. But once that table has grown beyond 64 KB, it will be assigned to a uniform extent. So that's about extents. Any other questions? Naveed? Adria?
David? Hello? 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 Can you hear me? Can you hear me?
Hello?
Hello?
Yeah, this is Ben here. I don't hear Naveed. Naveed, you there?
Hello?
Yeah.
Hello?
Naveed?
Hello, Ben?
Yeah,
Yeah,
I'm
is
here.
everything done?
Yeah, I just completed on this one particular topic.
Okay.
So should I go forward or is there any questions?
Okay. Hello, Naveed. Hello?
Female planet.
Yan aja kamu.
Okay.
Hello?
Fine. So if Naveed, if you have any questions, just I'll at least put it in the chat box so I'll try to clarify it.
ఏంటి నువ్వు పెద్దవాగుడు నువ్వు
Yeah, Naveen, these topics, it's a different topic as it is in indexes because it's a huge topic. Right now, I'll just plan to cover the basics about from the fundamental units, about the pages and extents and the structures. Indexes will be covered in the later sessions going forward. It's a huge topic and it is an important topic when it comes to a DBA perspective. Okay, it will help you in performance tuning. It will be helping you to improve the performance of a particular retrieval process. So I'll be explaining those in case we get the opportunity to talk about in the future. Okay? Okay. Eritrea, any other questions?
No, I'm okay so
Yeah.
far.
Good. Aditya, can I go forward with the next slide? Set of slides?
Sure.
Okay.
yeah Ben, you can go that.
Okay. Okay, now we'll talk about databases. What is a database? So we know what is a database. So database is nothing but a structure which would have multiple kind of objects which will be used by a particular application or multiple application. So when you talk in scenarios as a DBA perspective, databases are used to contain data which will be related to the application. Right? Every data that is used by a particular application will be stored in the database, which will be used for retrieval purpose. So every database will have three kinds of files. The major types of files is the data file and the log file. And within the data file, there is a primary data file and the secondary data file. Okay. So when you create a new database by statement like create database name, by default there will be two data files created. One is the primary data file and then the log file. But in case you want multiple data files, which will be stored in different drives, in that case, those files are called a secondary data file. Okay, so having a secondary data file has multiple advantages. One, when you want to retrieve a data, that you can actually assign a particular object or a group of objects to be under a particular file. So for example, you have a database about 1 TB, okay, but your SAN, your space or your data disk doesn't have enough space to hold in 1 TB. So what do? You split. You have but two 500 GB or two 600 GB databases, 600 GB drives. So what do? You create one file in one drive and second file in the second drive. So when the first drive fills up, it will use the second file, right? So that in that case, in that way, you can manage the space in a particular server. Also, when you want to retrieve data, you don't have to read from one particular file. You can read it from the different file, which is allocated for a particular group of objects. So these things will help you to improve your performance when you comes to reading data. Okay.
Okay.
So by default, the primary file is called is having an extension called .mdf. It is not necessary that we give .mdf. Or these are the recommendations that is given by Microsoft when you create a database. So in case in future you want to find out what is a primary file, a data file, or do you want some manipulation with these files, you'll be able to understand what kind of file. As it is, these files doesn't have any extensions, but for understanding of a DBA, we should be creating the primary data file as .mdf and the secondary data file by .mdf extensions. Okay, and the log file will have the log information that is used to recover database. So log file is, or the transaction log file, will have the information of the transactions that are logged into that particular database, and that log file is used when the database goes down and when it comes back again. For some reason the server went down, has crashed or something, or was shut down, and when you then start up this server again, you don't want to lose some data, right? For example, there's a server and there was some transaction going on. So all of a sudden, due to some power failure or some hard disk failure, the server has crashed. So when they bring it back up, you don't want to lose the data that was running, right? So in that case, to recover the database from and bringing it to a consistent structure, we use the log files. Okay, we have the same concepts across every other RDBMS like Oracle and MySQL. Okay, and so by recommendation by Microsoft is that the file extension of the log file should be .ldf. There's no limitation for the secondary files. This is just like a data file. Okay, there is no restriction as it is. It is just like the primary data file, but the secondary data files are used in case you want to keep this. You want to spread across the database files in different drives. So in that scenario, we create this secondary data files, and those files doesn't have any limitations as in relation to space. Okay. Does that answer your question, Amit? Hello? Yeah, we can have multiple secondary files. Yes. You can only have one primary file, and the rest of them can be secondary files, which can be spread across different drives, or it can be kept in the same drive. Doesn't matter. Okay. Okay. Going forward. So when you talk about it,
can I ask you a quick question regarding secondary file?
Yeah, okay.
So the prime always is for us to have a prime MDF and IDF, right? Which is a primary file and the transactional file.
Yeah, okay.
So if the secondary file is not necessary, what is the advantage having a secondary file?
So, that's what I was trying to understand. Maybe as I said earlier, okay, you have two 500 GB drives to keep the database. Okay, I'm talking the DBA perspective. Okay, so when the application was created, okay, the application had a backend database assigned to it. I mean that for the database there's a different physical server assigned. And that physical server, they have allocated two SAN drives. You must have heard about the word SAN drives. SAN drives. These are called storage area network. Everyone uses it nowadays. No one uses the physical disk like we use in our laptops or desktops. When it comes to production servers, when we're talking about deep terabytes of data, and so we use SAN drives. And these SAN drives are allocated. So every application will be trying to use multiple SAN drives assigned to it. And in that case, there's only one database assigned for that particular application. So in that SQL server, there's only one database assigned. But as time grown, it was assigned to one particular drive. So there was one MDF file and one LDF file. So that was there in, for example, it is in D drive. But as time passed, the data increased in size and it has come near to 500 GB, right? Now, since the SAN drive is only 500 GB, you can't do any more insertion, right? So in that case, it will help you create a different database file or the secondary data file in the second drive, right? You have two drives of 500 GB each. So once the 500 GB is filled up in this, you have created a different file in the other drive. So now the file can grow in the database can grow in the other drive. So that's one advantage of having a secondary data file. It is not necessary that you have to create a secondary data file, but this is one scenario where you can have a secondary data file. Okay? And then there are other scenarios where for example, we consider a database which is about 1 TB. Okay? But only some tables in that particular database is important for the application. But there are lots of tables in that application, but a group of tables are important for the application. So what we do is that while you create those tables, you will assign it to a file group. I'll come across that term later. And that file group can belong to a different secondary data file. So whenever you want to retrieve the data, you don't have to hit the primary data file. You can read it directly from the secondary data file. So the IOs will be reduced. When you talk about IOs, means input-output operations will be reduced, right? Because it is being spread across the network rather than always pointing to one particular physical server. For example, think about a scenario when thousands of users are trying to access only one particular file all the time, right? So when it goes to network, there will be a network bottleneck, that means a network contention. To avoid those things, you spread across tables and keep them in different file groups which belong to a different data file, which is called a secondary data file. So these are taken care of while a database is created by the database architecture, because they will do some sort of forecasting. They are trying to understand what are the important tables in that particular database, how much growth can you expect in the next 3 years, right? So considering all these calculations, they come up about the database design. Okay. So in that picture, we have seen a secondary data file being created in a different drive, or it can be the same drive, doesn't matter. So does that answer your question?
Correct.
No?
Yeah, that's
Okay.
correct.
Yeah. More you start working on it, you'll come to understand how it exactly comes into picture. So when you add a data into it, the SQL Server would be able to see one thing, it will be added serially, right? So when data is added into the primary data file and the primary data file is filled up, only then the secondary data file comes into picture. Or else in the scenario when I spoke that some tables are assigned for particular data file or file group. In that case, when you do insertion for that particular tables, that data file will go. Okay? We'll try to simulate these situations. Let me see if I can do that. See over here, you see that, right? There is a primary data file, okay, and a secondary data file which will be created by default. So usually it is by default, there is no restriction in the growth. It will be growing and as long as there is space in the drive. And you can name it like test 02.india test 02.india. This is the log file and this is the data file. So this is what I was talking about, file groups. So there's only one file group right now created by default, which is called a primary file group. The primary file group will be the primary data file. So, but you can change it when you create one more. You can create additional files. So when you create a file, you can ask you rows data or log. So you mention a rows data, that means it will become okay. So now we have a secondary file, a log file, and a primary file. Okay, this is how it has been. You can assign the sizes of it, initial size of it, how much you want. Those things will come back later. So now you have new database. Okay. So initially size of the database is 5 MB because we have two tables of size, two database files of 2 MB, 2 MBs and one log file of 1 MB. So right now this is how the size is. Now let's try to create a table. So this is the data type. Save table as Mm. Okay. Set this as a identity column. Sure, leave it. So here we are trying to insert about 100,000 records. So, do you guys have SQL Server installed in your? Do you have a copy of SQL Server installed in your machines? Do you have it in your laptops or something?
I do.
Okay. David? So, please try to install it so it will help you to understand more and try to work out things by yourself. You'll understand things how it works. Now you can see it hasn't drawn actually because when you think about it, BN 3 plus 4, 400,000, 400,000, 400,000 bytes. This just has to be 390 kilobytes, whatever we have added right now. That's the reason you don't see any difference in the sizes. Sizes remain the same, right? So if you do a much bigger insertion, you can try it out, see how the file goes. Try to insert a million records, so for bigger size. Like here. That's it. Okay. So while it runs, let's go forward with our PPTs, the slides, and we'll just come back and see how it has grown. Okay. Okay. So we're talking about this. So each file, we have file ID, So if you have a secondary file, the file ID will be like file ID 2. And if you check it out here, you see right when I run SPL so you will see the file IDs. So each file has a particular file ID. And the file IDs will have, but we were talking about pages, so everything is under pages, right? So the file ID will have a set of pages, and the second file ID will have, the second file will have a different set of pages. So that's how they uniquely understand which page to be retrieved, because we have the, when you look at the page address, the page address will have the file ID, the object allocation unit ID. In that way, we can understand which data file does it belong to and which table it belongs to. So the page can be found out by that. Okay. So pages in the SQL Server data file are numbered sequentially starting with 0 for the first file. Each database has a unique file ID number. To uniquely identify a page in a database, both file ID and the page number are required. So to identify a particular page in a particular database, we need to have the file ID as well as page number. And that, so that's about pages and structures. It's still executing. It's going to take a longer time. Anyways. So now, Aditya, can I go forward with the next slide, or what's the plan? Aditya, you there?
I'm here. Can you hear me?
Yeah,
Hello?
I can hear
Ben?
you, but I'm checking. Yeah, I can hear you, but I'm talking to Aditya. You there, Aditya?
Yeah, I'm here. Can you hear me?
Yeah. Checking out for the train. Okay, in that case, I'll go forward with the next slide. So we were talking about what is a log file. So we just have a little go through about what is a transaction log file and what's the architecture. So what transaction log file does is that it will have a log record of every transaction that is done. Okay. So for example, when you're doing insertion of some data, insertion of 10 rows into a table, the transaction log will have the details saying that 10 rows have been updated and what are the pages involved in that row. Those details will be there in the transaction log file. Once data is committed, based on the recovery model, which we may speak later in the coming sessions, the data will be either present or will be truncated out once data is committed. So log file, and it's a string of log records which makes up a transaction log. And each log record will be identified by a log sequence number. Right? And like we have in the pages, we have the page ID. These log records are identified by the log sequence number. and each new log is returned to the logical end of the log. So that makes it to be added serially. So when a new transaction is executed, the executed transaction will be written to the logical end of the log with the LSN number that is higher than the previous one. So these transaction log, the whole purpose of having a log is for database recovery. Okay. Whenever, like I've talked about this previous scenario, so whenever data system shutdown or system failure or database corruption, to get it back to the consistent state, we would require the log file. So without the log file, database cannot be consistent. Okay. So log records are stored in a serial sequence as they are created. Each log record contains the ID of the transaction that it belongs to. So every transaction will have a particular transaction ID, and the log record will have the transaction ID of that particular transaction which contains. For each transaction, all log records associated with the transaction are individually linked in a chain using backward pointers. Okay, you must have learned about linked list or kind of pointers where yeah. Okay. So these, you must have heard about linked list or data structures where the previous structure is linked to the structures are linked to each other by pointers, so that when you want to do a rollback. So when you talk about rollback is a situation where you run a transaction, but you don't want that transaction to be there in the server. Okay, so in that case, you want to roll it back. Whatever change that is made in the database, you want to roll it back. You can give a state as long as the transaction is not committed. You can always roll back. So to help in this process, we have these log records which have backward pointers. So we can go back to the session where the changes were to this previous situation before the changes were done. Maybe I could try it. I guess you must know what is a rollback, right? Ezra or Naveed? Okay. In that case, go forward. So this is something that helps you in the rollback or roll forward, which will come back later. Okay. So what are the operations that are recorded in the transaction log? This is explained here. So every start and the end of a transaction is logged in the transaction log. And every modification, any DML queries that you run on a particular database or any DDL queries as well will be recorded in the transaction log. If a new extent is allocated or a page is allocated or deallocated, this will be recorded in the transaction log. So if a new table is created or new index is created or dropped, in that scenarios, these details are also logged in the transaction log file. So what is active log? So when active log would contain the data which is uncommitted, right? So uncommitted data which can be rolled back will be put in the active part of the log. And this is a section of the log required to do the full recovery of the database. So whenever there's a database to be recovered from a crash or something, we use this active log to decide whether it has to be rolled forward or rolled back. These are the part of the transactions which are active at the point of time. So transaction log in a database maps over one or more physical files. We can have multiple log files, but it is serially added. The log file is a string of log records. Physically, the sequence of log records is stored efficiently in a set of physical files that implement the transaction log. So the transaction log can be spread across in multiple log files, but it is added serially. So once log file is full, the second log file is used up. But internally what happens is that the database engine actually divides the physical log file into multiple virtual log files, or called VLFs. These VLFs have no fixed size. These are dynamically assigned by the SQL Server database engine, and it chooses the virtual size of the log dynamically while it is creating and extending the log files. So in the beginning we saw that log file was the size of 1 MB, but as more transaction comes in, the log file size would change. If you see here, the log file is right now 9 MB, but it is not increasing in this scenario. But you see here the log space used keeps changing. Main reason because of this kind of transaction is that this is not one single transaction. This is a multiple transaction running in a loop. So each time one transaction is completed, it is committing the transaction, and then this next one is starting up. That's the reason we are not seeing the log file going up. Otherwise, if it was just one condition, like if it was under the while loop, it would have run as one transaction. But here, since it has been broken down to multiple transactions of 1 million transactions, that's the reason the log file is not going up much. But here you can see, yeah, the log file size is 9 MB and the space used inside the log file is 6 MB. Just do that. Yeah, when Aditya had asked what is the log file, right now you see, right, both the files have grown actually at the same time. That's the mistake I made. When it comes to log files, it grows serially. So if you have two log files, if the first one completes, the second log file grows. But when it comes to data files, they grow together. See, sizes of it are almost similar at all times. Naveed? Yeah. Yeah. So that's what has happened. So that's the mistake I made. The log file is the one that grows sequentially. So if you have two log files, the first log file will be filled up, and then the second log file is filled up. But when it comes to data files, if you have multiple data files, everything pointing to the same object. But I told you there's a different scenario when you have a particular file group assigned to a secondary data file. In that case, only when that those tables are assigned, there are some insertions happening on those tables. Only in that case that particular data file will grow. Otherwise, it won't grow. But in this scenario, we didn't assign a particular table to be under a particular file group, right? We have assigned both of them are right now under same primary file group, and because it is in the primary file group, the data is being spread across uh, uh, evenly. So you'll see that both the data files will be growing the same size. Okay, I'll better stop this. So that answers our question. In this scenario, it didn't roll back because it is single transactions of insertion statement. Okay, going back to transaction log file. Any questions? In that case, it will do the same thing. Yeah, Naveed. So as long as it belongs to a particular database where you don't have different file groups created, just one particular primary file group. In that scenario, it will be the data will be spread across in two at the same time. That's the reason when as a DBA you should understand why you should create a secondary data file, right? Because it will be if you are inserting data into the same object, but in different drives, it will help you because every drive has disk has a spindle, right? The same spindle can be split. So two different spindles can be used to write data into two different disks. So work will be much more faster in writing data into the drives. So that's how you spread out the data. Okay. So this is our structure of the word transaction log file, transaction log. So whenever you see this part of it is the active part of the log, active log, where there is a transaction right now going on which is not committed. So these transactions will stay as active part of the log. So whichever is being the blue side of it, the virtual logs which is marked in blue, which would signify the transaction logs which are already committed by the transaction by the SQL server. So once it is being committed, either if it is in a simple recovery model, it will be truncated automatically. If it is in full recovery model, it will stay there so that you can take a backup of the transaction log file. So this is the starting point of the transaction log file of the active part, and this is so every log file, every VLF will have log record will have particular LSN number, right? The log sequence number. So this is the LSN, minimum LSN, and this is the end of it. So when a new record has to be inserted, it will be inserted into the unused space of the VLF. Right? Once you reach the end of it, it can again come back to the beginning to the beginning session of the virtual log file, so that you can reuse the log file. So you don't have to again create a new log file. If it is in simple recovery model, you can reuse the log file. If it is in full recovery model, you have to take the backup of the log file. Once you take the backup of the log file, other than the active part of the log file, everything else gets truncated. So that once it is truncated, you can again start using up the log file for the rest of the transactions that will be coming up. Okay. Okay. So for today, I'll like to stop it over here because checkpoint. Okay, I'll just complete checkpoints. What else is left? Yeah, I'll just complete what is a checkpoint, and then we'll wind up the session for today. So checkpoints talks about what a checkpoint does is it will flush out the dirty data pages from the buffer cache of the current database to the disk. So I've told you before in the beginning of the class that if you want to retrieve some data for the application purpose, first the pages are read to the memory, and from the memory it is given to the application. So the memory part which is used by the SQL Server is called the buffer cache. Okay. So what buffer cache does is that, so for example, you want to update some data in a particular row. So what happens is that first the SQL Server will find out where does that particular row reside. So it will pick up which is the page, it will identify which is a extent which contains this particular object. Once the extent is identified, it will go to the particular page which will have this particular row of data, and then the row data, the page is moved to the buffer cache. Once it is in the buffer cache, you do the modification. You run update and update something ID equal to 4 when ID is equal to 1. You mention that, then the page is changed, right? The data inside the page is changed now. Once it is changed in the buffer cache, it becomes a dirty page. So what checkpoint does is that it will flush this changed page or the dirty page back to the disk. Okay? That process is called flushing out or hardening. This minimizes the active portion of the log that must be processed during the full recovery of a database. See, if everything keeps on residing in the buffer cache, nothing is there on the disk, right? So on a constant basis, so if the server fails, right, everything has to be recovered from the log file. So log file will keep on increasing, and it has to read from the log file whatever transactions that are done. So to minimize that portion of the log file, we have to flush it. The checkpoint helps you to keep the data consistent on a regular basis. So even if you fail, you will have minimum data loss. Okay? And the log records of modification not flushed to disk before the system stopped are rolled forward. So whatever the records that are there in the log file will be rolled forward when the system is stopped. So when the system is stopped, what happens is that you have some transactions that is there in the log file, but it is not changed in the data pages. So what it does is that whatever is there in the log file, it will be directly moved to the disk, which will help you once the database is up to it will be the log file, whatever changed is there, it will be applied it on the databases. So that is called the redo phase. So when you talk about SQL Server database recovery, we have three phases. That is analysis phase, redo phase, undo phase. So analysis phase, it will find out which are the pages, what are all the details that is required. What are databases, pages, what's the consistency level of the pages, all the details. In redo phase, it will find out what are the transactions that are committed but that are not logged in the database. So that the transactions will be flushed into the pages, data pages. That is called the redo phase. That it is helped by the log records of by this step, by the checkpoint. And if there are any incomplete transactions where there is no commit or rollback, those situations, it will be, those incomplete transactions will be rolled back. So it will not be applied on the log file if it is not committed. This is some of the checkpoint functionalities. Then checkpoint performs a foreign process in the database. So what it does is being written down. So what checkpoint does is it will write a record to the log file marking the start of the checkpoint. It will store the information recorded for the checkpoint in a chain of checkpoint log records. And if the database uses simple recovery model, it will mark the reuse of space that precedes the minimum LSM. So I said that in the simple recovery model, once checkpoint is issued, you can reuse the log file. You don't have to increase the size of the log file. Existing log file can be reused. You saw that before, the log file wasn't growing. When you were doing the thousands of insertions, the log file didn't grow. Because, why it didn't happen? Because it was reusing the existing size of the log file. So that helps you to reduce the size of the log file from growing. And another operation that is done by checkpoint is it will write all the dirty log and data pages to disk. Right. This is what I said before. So any changed, so dirty log file or data page means a changed page. A page which is changed in the memory but it is not been applied on a disk is called a dirty page. So those pages have to be applied on the disk because every the database is actually physically residing in the disk. So that's the reason we should have all the pages written to disk so that you can have minimum data loss. And at the end of it, it will mark the end of the checkpoint in the log file. So the log file will mark saying that the checkpoint was ended. So now we'll look into scenarios where the checkpoint gets issued. So you can manually explicitly execute the checkpoint statement when you want. Okay, so you can type in checkpoint and execute it. It will issue the checkpoint. Second scenario is that whenever you're doing a bulk insertion in a bulk locked recovery model. So there are 3 recovery models which we may cover in the future sessions. So one is bulk locked recovery. So whenever you're doing a bulk insertions or bulk select, not a bulk select, bulk insertions mainly when it is done, it is better to use the bulk locked recovery model so that every operation is not required to be logged in the database. Because if that is done, the log file grows so big a size that the database can even fail. So that's the reason we use particular bulk locked recovery model. And in that scenario also a checkpoint gets issued. And whenever you are adding a new database file or whenever you're removing a particular database file from a database, a checkpoint is also issued. And when instances when the SQL server is shut down, okay, the SQL server is whenever it is shut down, a checkpoint is issued, which will move the pages from the buffer cache to the disk. And then also there is a periodically it runs a checkpoint on each database so that it can reduce the recovery time of a database. And lastly, I believe it is whenever you take a backup of a database, which is a major work by the database administrator, whenever you take a backup of the database, the checkpoint is issued and that will also clear up the log files. Sorry, it will clear up the buffer cache. So that's all I have for today. So if you have any questions, please let me know. Or else you can send a mail to Aditya posting out the questions so that can be shared across. I'll try to answer those. Anyone, any questions?
Hello. Hello, Ben.
Yeah.
Yeah. Is everything done for today?
Yeah, it's done.
Okay. So you're ready for questions.
Yeah. Yes.
Ben,
Yeah. Mm-hmm.
after each class when you teach, are you going to be able to email the PowerPoint or?
Yes. I will do that, Ben. Hello.
Hello.
Yes.
Yeah.
Eritrea, yeah, I'll email you the recording session and all everything. This PowerPoint, whatever he explained you up to now.
Okay. Thank
Okay, don't worry about it. Any more questions that you want to ask him right now? Hello?
you. I guess it will be regarding as a whole in class.
Okay.
Like how long would the whole class last? Normally, how many weeks or?
Hello?
Hello, can you hear me, Ben?
Yeah, Ben? Hello, Ben?
Yeah.
How long does the class, the DBA class?
Of course.
Yeah. So, Aditya, can you tell her what is the timings? I'm not sure about the timings.
I'll let you know. I'll let you know it, yeah, through phone. Okay?
Okay.
Okay, don't worry. So everything done. Navid? Hello?
He's
Navid, yeah.
uh,
Do you have any more questions? Okay.
okay. So, guys, while you study itself, try to learn more by yourself. Try experimenting. Try to install SQL Server in your machines, laptops. Try to work out various scenarios that will help you in your future. So,
Okay, Ben.
rather
Thanks,
than doing
thanks for
things
your
waste.
precious
Okay.
time. Okay, we'll meet you again.
Yeah.
Okay,
Okay
thank
then.
you. And I'm closing down this
Yes. Thank
session.
you.
Thank you, Ben.
Okay,
Thank you.
thank you, Trias. Thank you, Navid.
Thank you.
Bye.
Bye-bye.
Yeah, see you later.
Bye. Bye.
Bye.